Hello students, in this video we are going to discuss pulse position modulation, right? This is one of the modulation technique. It comes under pulse type modulation, right? As the name itself indicates, so we are varying the position of our carrier pulse in accordance with the amplitude of modulating signal, right? So here we are keeping the amplitude and width are constant. Just here we are varying the position of our carrier pulse. So we will see how we are going to generate PPM signal, how we are going to detect PPM signal, and advantages and disadvantages. Okay, so this is the PPM signal generation block diagram. Okay, so till now we have discussed in the PWM how we are going to generate PWM signal. There itself we have given the monostable multivibrator circuit in order to generate PPM signal, right? We will discuss in detail how it is PPM signal generates from this block diagram, from this circuit. Okay, actually it is not exact circuit, it is like a block diagram. Okay, so first we are giving the modulating signal at the non-inverting comparator, non-inverting terminal of the comparator, and sawtooth signal is given to the inverting terminal of the comparator. So when the amplitude of modulating signal is greater than the sawtooth signal, then your comparator output is high. Otherwise, it is low, right? So based on that, we are going to generate PWM signal, right? So after that, that PMW signal is the input of our monostable multivibrator, right? Why we are using this monostable multivibrator circuit? You have studied in your electronic circuits too, right? As it in the chapter 4, monostable, astable, bistable multivibrator. It is generates the square wave pulse or rectangular pulse, right? So here, as it is a monostable multivibrator, so we have one stable state and another one is a quasi-stable state. What is stable state? Either it is a off or on. Quasi-stable state is it is either half or on. It is not complete off or complete on. It is either off or on. It is not in stable state. We call that one as an unstable state. It is, we can also call that one as unstable. Quasi-stable state is also called unstable state, right? So actually monostable multivibrator circuit is used for the application of timer, delay circuit and generating the pulses. So we are using that. Here in order to generate the rectangular pulses only we are using. So here it is triggering at the negative edge. It is triggering at the negative edge. Whenever the PWM signal have a falling edge, we can also call that one as a trailing edge or negative edge. The monostable multivibrator triggers and it shifts the position of PWM signal according to our modulating signal. So we will see the waveform, right? Then we will understand in detail. Okay, so this is my modulating signal, right? Um, this is my modulating signal, which means it is my original signal. This is my PWM output. So this one we are getting at the output of comparator, right? So we have discussed in detail in our last video. So here, so based on our amplitude of modulating signal, my my PWM pulses are shifted, which means we will get the pulse position modulating signal. How it will, we will discuss. Okay, see here, this is my reference line. So this is my the dotted vertical dotted line is my reference line. Okay, so here based on this reference line our and amplitude of modulating signal, my ppm signal my ppm signal it shifts the position, right? So see here, so this is my reference line. So here my amplitude of modulated signal is very low. My ppm signal is shifted away from the reference line. It is not near to the reference line, it is away from the reference line. As my amplitude of the modulating signal is goes on increases, my ppm signal moves away from the reference line. Okay, so during the negative half cycle, my ppm signal is very near to the reference line. It is very near to the reference line. Okay, so in this way, so based on the amplitude of modulating signal, my ppm signal is moves shifted to away from the reference line and towards the reference line. So in this way, so we are going to generate ppm signals or pulses. Okay, so now we will discuss how we are detecting, how we are demodulating our original signal, right? So here, so by using this circuit we will discuss. Okay, so this is our ppm signal demodulator circuit. Here we are using pulse generator, reference pulse generator. This is a SR flip-flop you have studied in your digital electronics, right? This is my PWM demodulator. So in order to get original signal, my which means modulating signal. Okay, so here I will give the ppm generated the ppm pulses as an input to the pulse generator. It will generate the rectangular pulses with some constant amplitude and fixed pulse width duration, right? Similarly, so I will give the same ppm pulses as an input to the reference pulse generator. It will also generate the pulse with the constant amplitude and fixed pulses. This pulse generated rectangular pulse will reset the SR flip-flop. This reference pulse generator set the flip-flop. So based on the triggering pulses, so we will get the PWM signal. Here it generates the rectangular pulse. We call that one as PWM pulses. So after that the PWM output, so we have to given as an input to the PWM demodulator because I want the original modulating signal I want to recover. So we have discussed in detail how we are generating, how we are recovering our original signal from the PWM demodulator. So finally we will get the modulating signal from the PWM, right? So here our ultimate goal is I need to modulate my input signal. First we are converted into the sample signal, analog to digital signal. Then I need to modulate that signal and then I will transmit that signal in the transmission medium. These are the different modulation technique, pulse based modulation technique. So we have many advantages in the pulse code based modulation technique when compared to the continuous pulse code modulation technique, right? So and also analog based modulation technique. So we have more advantages except the bandwidth, right? So when converting analog to digital, we need more number of bits. That's why my transmission bandwidth is also high. So that is one of the major drawback in our digital pulse code modulation technique, especially in the digital pulse code modulation. So we will discuss the advantage of PPM. So as we are shifting the pulses, so here amplitude is constant. So amplitude does not contain any user information, right? So here that noise does not affect the ppm signal, right? Even if it is effect, we can easily remove the noise from the PPM signal. And also here, as the amplitude is constant in the PPM signal, so we are not varying the amplitude. We are not varying the amplitude with, just we are shifting the pulses. So here the transmission power is also constant, because here we are not varying the amplitude. If they are varying the amplitude and with your transmission power gets varied. Here amplitude is constant and also user information does not contains. So here transmission power is constant. And the disadvantage is, as I said, it is a digital pulse code modulation. So we need transmission bandwidth high, and one more is, here we need synchronization circuit between transmitter and receiver. These are the two main drawback in our pulse position modulation. Okay. Uh, I hope you are able to understand this concept, pulse position modulation technique. So generation, detection, advantages and disadvantages, we'll see in the next video. Thank you.